What if a $1 mixture from your kitchen pantry extends your air conditioner's life by 5 to 7 years? And why does almost every service shop in the trade refuse to put it in the maintenance plan they charge you for? It's not a gimmick, it's not a hack, and it's not new. The product has been sitting under most American kitchen sinks for the last 40 years. The technique takes about 20 minutes once a year. The reason the trade doesn't push it on you is the same reason a $12 capacitor turns into a $200 service call. There's no money in telling you the cheap fix. 28 years in the trade, working out of a service van across 3 different states, and I've watched the maintenance plan pricing structure get more aggressive every year. Started my apprenticeship in Ohio, ran service in Pennsylvania for 6 years. Eventually started my own small company in Texas where I've been running calls for the last 18 seasons. The dollar mixture I'm about to walk through is on my service van right now, in a plain pump sprayer that cost me $4 at the supply house 10 years ago. I've cleaned probably 800 condenser coils with it. Stick around to the end because there's a cleaning direction most homeowners get wrong and most contractors skip on rushed maintenance visits. And there's a 5-minute verification check with a magnetic thermometer that tells you whether the cleaning actually worked. Before any of this, quick reality check on what we're cleaning and why it matters. The outdoor unit on your air conditioning system has a metal coil wrapped around it, called the condenser coil. That coil is where the refrigerant inside your system dumps the heat it pulled out of your house. Picture a car radiator. Same principle. Air gets pulled through the metal fins by the fan on top. The heat transfers from the refrigerant to the air, and the hot air exhausts upward. If those fins get coated in dirt, pollen, grass clippings, cooking grease from the kitchen exhaust, vehicle exhaust if you live near a road, and the general atmospheric film that settles on every outdoor surface in your neighborhood, the heat transfer drops. Drops by how much? A study from Lawrence Berkeley National Laboratory back in 2014 measured heat rejection efficiency on residential condenser coils across various fouling levels. A moderately dirty coil with what they classified as visible surface dust and pollen accumulation lost about 15% of its rated heat rejection capacity. A heavily fouled coil with what they called caked organic and inorganic deposits lost up to 30%. Translated into your electric bill, that 30% loss turns a $300 July bill into about a $390 bill for the same indoor comfort. Same house, same thermostat setting, same weather. The only variable is what's on the coil. And here's where it gets expensive over the long haul, in a way the maintenance plan crowd will never highlight for you. When the coil can't reject heat, the refrigerant pressure on the high side of the compressor climbs. Compressors are designed to operate within a specific pressure range. Push them past that range repeatedly, and the internal motor windings overheat, the oil starts to degrade, and the mechanical wear curve accelerates. The honest number from manufacturer engineering bulletins, the kind Carrier, Trane, and Lennox publish for their own service technicians, is that compressor life on a system run with chronically dirty coils averages 8 to 10 years before failure. Same equipment run with annual coil cleaning averages 15 to 18 years. That's an 8-year delta. On a $3,000 compressor replacement, that delta is real money. Here's the dollar mixture itself. You need 2 ingredients, both already in your house. 1. Plain blue Dawn dish soap, the original formula, not the splash-resistant version, not the antibacterial version, just the original blue. 2. Water from your garden hose. The ratio is 2 tablespoons of dish soap per gallon of water, which is roughly the amount of soap in a single coffee mug per a gallon jug. The cost of 2 tablespoons of Dawn out of a $4 bottle is approximately 25 cents. The water is essentially free. Add another 50 cents for the pump sprayer amortized over 5 years of use. You're at maybe $1 all in for a single coil treatment. Why dish soap specifically? Dawn was originally engineered to break the surface tension of grease, which is why it's used on oil-covered wildlife after spills. The same surfactant chemistry that lifts grease off a duck's feathers lifts the airborne cooking oil, vehicle exhaust film, and atmospheric pollutant residue off your condenser fins. Plain water alone can't do this. Water beads up on greasy surfaces and runs off without penetrating the film. The dish soap surfactant lowers the water's surface tension enough that the mixture actually wets the dirty fin surface, dissolves the bonded film, and rinses away when you follow up with clear water. The commercial foaming coil cleaner that service shops sell for $40 to $50 per can is using the exact same chemistry, alkyl polyglycoside surfactants, and a few corrosion inhibitors at a markup that would embarrass a car dealer. Compare your lifetime cost on this. The average maintenance plan from a residential HVAC service company runs $189 per spring visit. Most homeowners stay in those plans for the life of the equipment, call it 16 years average. That's 28 visits over the system's life. 16 times 189 is roughly $3,000 spent on what is essentially coil cleaning, a filter check, and a refrigerant pressure reading. The dish soap version costs you $1 a year. $20 over the same 16-year span. The difference, almost $3,000, would buy you the new system itself when this one finally retires. Nobody scammed you. The plan just never told you the actual product was $1 and the labor was 20 minutes. If you've owned your home for any amount of time, you've probably noticed something without being able to name it. Some summers your electric bill is reasonable. Other summers it spikes for no obvious reason and you blame the weather. Part of it, maybe most of it, was a coil slowly fouling up with film you couldn't see and a compressor straining a little harder every cycle to do the same work. The system never told you anything was wrong because the indoor air still felt cool. It just cost more every month to feel that way. 20 years of homeowners noticing that pattern without anyone telling them what it actually was, and the maintenance plan they paid for never moved the needle because the techs on that route are pushed to hit 15 houses a day. The math on a 15-house schedule does not allow time for a real coil cleaning. They hose the outside, write up the ticket, and drive to the next one. A buddy of mine who runs his own small shop in Phoenix told me he stopped offering the standard maintenance plan to his customers 10 years ago. Switched to a flat $50 per call coil cleaning service with a written guarantee that if their July bill didn't drop measurably year over year, he refunded the visit. He told me his refund rate has been under 2% across roughly 400 customers. In Phoenix, where the dust load on outdoor coils is heavier than almost anywhere in the country, with grit blowing in off the desert and pollen layering up during the spring bloom, a clean coil makes a documented difference on the electric bill every single time. Sample of one shop, not a controlled study, but the data lines up with what I see on my own route. Before you actually run the procedure, take a Saturday morning when it's not raining and the system has been off for at least an hour, which keeps you from working on a hot pressurized unit. Cool morning hours are best because the thin metal cools off and any condensation from the cleaning rinses off without flashing to steam. Pull the disconnect on the outdoor unit before you touch anything. That's the gray box mounted on the wall next to the condenser, usually about eye level. Pull the handle out, set it on top of the box. The unit is dead at that point. Don't trust the breaker, don't trust your memory, pull the disconnect. Quick reminder on what's safe to do yourself. Anything that touches refrigerant requires EPA 608 certification under federal law. That's not a state thing, and it's not negotiable. The procedure we're talking about today involves no refrigerant work whatsoever. You're cleaning the outside of the coil. The refrigerant stays sealed inside the copper tubing the whole time. As long as you stay outside the system and don't bend the fins past the point of recovery, you're not doing anything that triggers the EOS certification requirement. Anything past visible inspection and external cleaning, including capacitor replacement on systems still under manufacturer warranty, can void parts coverage, so check your paperwork before you grab a screwdriver. If you're getting value out of this, hit subscribe. We've got more of these coming. Back to it. The standard procedure most homeowners run. Pull the top grill off the condenser, which is usually held in place with 4 to 6 sheet metal screws around the rim of the top cabinet. Lift the grill and fan motor assembly straight up about 6 inches, just enough to set it aside on the ground without stressing the wiring harness running from the fan motor down into the electrical compartment. The coil is visible from inside the cabinet at this point. Rinse the coil first with plain water from your garden hose on the lowest pressure setting, working from top to bottom on the outside of the fins. This pre-rinse knocks off any loose surface debris. Total time, about 3 minutes. Then apply the dish soap mixture using the pump sprayer. Spray the entire outer surface of the coil, working in horizontal passes from top to bottom, making sure you've coated every visible fin section. Let it sit for 10 to 15 minutes. The surfactants need time to break down the bonded film. While you're waiting, you can clean the top fan grill with the same mixture, wipe down the top of the cabinet, and check the contactor terminals for any visible corrosion through the access panel. Coming back to the coil after 15 minutes, rinse thoroughly with clear water from your hose, again on low pressure, again working top to bottom. Reinstall the fan grill, restore the disconnect, and run the system for 30 minutes on a hot afternoon to verify everything is working. I'll be honest, the first time I tried this procedure as a brand new apprentice in Ohio, I made 2 mistakes that cost me about an hour of rework. First, I used a pressure washer instead of a garden hose because I thought higher pressure equaled better cleaning. Bent every fin on the front face of the coil. Spent the next 40 minutes straightening fins with a fin comb, which is a small metal tooth tool that pulls flattened aluminum fins back to their original spacing. Lesson: pressure washers are too aggressive for residential coil fins. Garden hose pressure, which runs about 60 psi on most residential supply lines, soft enough to wash a car without paint damage, is exactly what you want. Second mistake: I used bleach in the dish soap mixture because the homeowner had told me his coil was moldy. Bleach corrodes aluminum fins on contact. Spotted the fins with permanent gray oxidation marks within a week. Never use bleach, never use ammonia, never use any acid-based cleaner on aluminum fin material. Plain Dawn and water. That's the formula. Quick counter-argument to address before the comments fill up with it. Yes, the maintenance plan technician who comes to your house twice a year may be using a slightly different surfactant blend with corrosion inhibitors specifically formulated for HVAC aluminum and copper. That's true on paper. In practice, the inhibitors matter on industrial commercial coils that get cleaned aggressively every quarter with high-volume chemical applications. On a residential system getting cleaned once a year with a mild Dawn solution and a low-pressure rinse, the corrosion risk is essentially zero. 40 years of homeowners doing exactly this on their own systems and posting their results on the HVAC Talk DIY forum have proven this out. The pros agree in private. They just don't agree out loud because the maintenance plan revenue depends on the perception that this requires a trained tech. Another counter-argument, vinegar is better than dish soap. I see this one in YouTube comments constantly. Vinegar is an acid. Acetic acid attacks aluminum over repeated exposure, leaving the fin surface microscopically pitted and creating new sites for corrosion to start. Vinegar is great for the indoor condensate drain line where the contact time is brief and the metal is mostly copper or PVC. On the aluminum condenser fin, vinegar slowly damages the material you're trying to protect. Stick with the dish soap and water mixture, which is pH neutral and rinses clean. There's also a third counter-argument that the foam coil cleaners labeled biodegradable and self-rinsing don't require a water rinse, which sounds convenient. The A label is technically accurate. The catch is that the residual surfactant left on the coil after evaporation attracts dust faster than a clean coil does, which means your next cleaning cycle comes around quicker. Plain water rinse after the dish soap soak removes the surfactant film entirely, leaves the fin metal clean, and resets the fouling timeline back to zero. The extra 5 minutes of rinsing saves you weeks of accumulation later. And the climax of the whole procedure, the part most homeowners and most contractors on rushed visits completely skip. The dirt is not evenly distributed across the coil thickness. Air gets pulled through the coil from the outside in toward the fan motor. The fan motor sits on top, the air gets exhausted upward, and the airflow direction across the fins is horizontal, outside to inside. That means the dirt loads up on the outer surface of the fins and gets pushed gradually deeper into the coil thickness over time. If you spray your cleaning solution from outside the unit inward, you're driving the dirt further into the fins instead of flushing it out. The contractor secret most don't admit to is to spray from inside the cabinet outward after pulling the top fan grill off. The clean rinse water pushes the dirt back the way it came in, out through the outer fin face, onto the ground around the unit. Lift that fan grill off the way I described earlier, set it aside, and now point your hose nozzle and your sprayer wand at the coil from inside the cabinet. The spray pattern goes from the inside of the cabinet, through the fins, and exits on the outside of the unit. You'll see brown water running down the outer face of the coil for the first 30 seconds. That brown water is the years of accumulated film, finally moving in the right direction. Do this same inside-out direction with your Dawn mixture, let it sit, then rinse from inside out again with clear water. You'll be amazed how much comes out of a coil that looked clean from the outside. One practical note on the inside-out rinse. The fan motor and electrical components inside the cabinet are sensitive to water spray, even with the disconnect pulled. Keep your hose nozzle aimed strictly horizontal at the coil and avoid spraying upward toward the fan motor mounting plate. If your sprayer or hose tip drifts upward, water can get into the top bearing of the fan motor or splash onto the contactor and capacitor terminals in the electrical compartment. Most contactor and capacitor enclosures have a panel cover, but the access cutouts where wires enter are not fully sealed. Cover the electrical compartment with a plastic grocery bag or a folded towel if you want extra protection. 2 minutes of prep before the rinse saves a $40 contactor replacement later. And one more note on the inside-out method that experienced techs know but rarely explain. The coil on most residential condensers is shaped like a wraparound, going around 3 or 4 sides of the cabinet in a continuous bend. Some premium brands like American Standard and Trane use what's called a spine fin coil, which looks like a series of metal needles instead of flat fins. The inside-out cleaning method works on both types, but the spine fin design rinses cleaner and faster, because the open structure lets water flush straight through without channeling. If you have a Trane or American Standard with the spine fin coil, you're going to see dramatic results from this technique. If you have a flat fin coil from most other brands, you may need to run the inside-out rinse twice with a 5-minute soak in between to get the same level of clean. On to the verification step. Pick up an inexpensive magnetic mount pipe thermometer from any HVAC supply house or Amazon, around $12 to $15. The model number doesn't matter much. Anything that reads accurately in the 30 to 80 degree Fahrenheit range with an indicator dial works. Before you clean the coil, run the system for 15 minutes on a warm afternoon and clip the magnetic thermometer onto the larger of the two copper lines running from the outdoor unit to the inside, which is the suction line, the cold one wrapped in black foam insulation. Peel back the foam at the service port near the unit, clip the thermometer onto the bare copper, read the temperature, write it down, run your cleaning procedure, then run the system for another 15 minutes after the cleaning. Read the suction line temperature. Again. You should see a 4 to 7 degree Fahrenheit drop, which is about the difference between a cold can of soda fresh from the fridge and one that's been sitting on the counter for 10 minutes. That drop is real evidence the heat transfer improved. If you see no temperature change after a thorough cleaning, you're in one of 3 situations. The coil was already clean enough that the cleaning didn't shift the numbers measurably, which is good news. You're on top of your maintenance. The fins are damaged or bent enough that airflow is restricted independent of cleanliness, which calls for fin comb work. Or the system has a different problem unrelated to the coil, possibly low refrigerant charge, in which case you're calling a pro who has the EPA 608 cert to handle it. One more situation where this whole procedure does not apply. Older systems running R22 refrigerant, the stuff phased out under the Clean Air Act, where any disturbance of the unit can stress already tired seals and trigger a leak. R22 is now running about $300 to $500 per pound on the few remaining supplies, and a major leak on an old system makes the repair versus replace decision lean hard toward replacement. If your system is 15 or more years old and you don't know what refrigerant it uses, check the data plate on the side of the condenser before you start. Anything labeled R22 means call a pro to inspect first. Anything labeled R410A or the newer R454B is fair game for this procedure. The supply house counter guy I grew up working with in Ohio used to say that the best thing a homeowner can do for their air conditioner is the cheapest thing the trade refuses to mention. 28 years later, I still think he was right. $1 a year, 20 minutes once a year, and you're adding 8 years to the life of a piece of equipment most people throw away early because the maintenance plan never actually did the one job that mattered. The cleaning is the maintenance. Everything else is filler. That's the procedure, the science, the cost math, and the verification. Pick a Saturday in spring before the cooling season hits hard. Give yourself an hour including cleanup and run it on your own unit. The brown water running off your coil during the inside-out rinse will tell you everything you need to know about whether the maintenance plan you've been paying for was actually doing the work. Once you know, you don't go back.